All right, part 3, slope-intercept form of the equation for a linear function. Okay, in chapter 5, part 5, we described a linear function in different ways. The linear function below represents the cost of a car rental. Okay, so we have a graph, car rental cost, so cost, distance driven. Okay, so an equation of this function is c equals 0.2 d's plus 60. Okay, the number 0.20 is the rate of change, or the slope of the graph. This is the cost in dollars for each additional 1 kilometer driven. The number 60 is the vertical intercept, or the y-intercept, of the graph. Okay, this is the cost in dollars that is independent of the distance driven. Okay, so it is the initial cost for renting the car. Okay, so that's how we ended up with this. So C was, okay, so the rate of change was 0.2. Now we're going to call that slope from now on. So 0.2 d's and then plus 60. That was the initial amount. Okay, so in general, any linear function can be described in what's called slope-intercept form. Okay, the slope-intercept form for the equation of a linear function. Okay, so an equation of a linear function can be written in the form y equals mx plus b, where m is the slope, okay, and b is the y-intercept. Okay, so y-intercept, that's always the vertical intercept. So on cases like this guy where it's a c, so I guess that would be the c-intercept, I suppose, to be really technical. Okay, but there's the formula, y equals mx plus b. Now this is probably the most important form because this is how you get into the general and standard forms as well. So we can almost kind of call this the gateway line, if you will. Okay. Anyways, let's show you how it works, because there's a little bit of algebra in here, and it's really not that big a deal. Okay, so example 1. Writing an equation of a linear function given its slope and y-intercept. So we'll have a look at this. The graph of a linear function has a slope of negative 7/3 and a y-intercept of 5. Write the equation for this function. Okay, well that's not so bad. Okay, this is the m, and then the y-intercept we're calling the b. So remember, that's y equals mx plus b. Now look, that is on your formula sheet, so you don't have to memorize it, but we're going to use this enough that you just will memorize this. Okay, so anyways, we just write in the slope, so y equals negative 7/3, haha, that's funny, negative 7/3 x, and then the y-intercept is positive 5, so we go plus 5. If it was negative 5, we would just put negative 5 there. It's not a big deal. Okay, so that's the slope of, or that's the equation of the line. Now look, you guys can see what's coming here. If I give you 2 points, you can figure out the slope between them, and then I might not give you the y-intercept, but then we can do some algebra to figure out what the y-intercept would be. Okay, we'll get there. So example 2, graphing a linear function given its equation in slope-intercept form. Okay, this is really nice. Okay, so graph the linear function with the equation that on the grid below. Okay, so the thing is, we can see from the graph that the slope is negative 3/4. Okay, so then if we have a starting point, we just take that point and go down 3, right 4, and yay, we've drawn our line. The problem is, where do you start from? Well, that's why this is so important. That's the y-intercept. So remember, there's the y-axis, there's the x-axis. So if the y-intercept is plus 2, so 1, 2, that is a point on the graph. So that's our starting point. And then from there, I go down 3, 1, 2, 3, and right positive 4. So 1, 2, 3, 4. So there's another point on our graph. So I can do it again, go 1, 2, 3 down, 1, 2, 3, 4 right. Now I can also go from that starting point, I can go up 3, right? Because this is also positive 3 over negative 4. We don't write it that way, but we can think of it that way. Okay, so up 3, 1, 2, 3, and left 4, 1, 2, 3, 4. Anyways, we only need 2 points to draw a line, so we've totally overkilled. But anyways, you connect the dots, and there you have your nice, awesome graph. Perfect. All right, next. So example 3, writing the equation of a linear function given its graph. Okay, so write an equation to describe this. Okay, so the first thing you notice, hey, the y-intercept is -3. So the b value is -3. Now we have to figure out the slope. So the slope we find, say, the next perfect point, so that's right there. So the slope of this silly line, okay, so we go up 1, 2, 3, 4. So the slope has a rise of 4. 1, 2, 3, 4, yep. And then a run of +2. So 4 over 2 is 2. So the slope is 2. So we go y equals mx plus b. Okay, well, the slope is 2. So 2x. And then the negative, or the y-intercept is -3. So 2x minus 3. And there is your line. Now, I've shown you guys how to graph these on your calculators. If you want to check, you could graph that on your calculator. Now, of course, the window settings are a little bit different, so it wouldn't look exactly the same as this. I guess you could change your window settings to that, so then you can get a better idea. But you can quite clearly see on your calculator that, hey, that's a line. It goes through the same points. Yeah, it's pretty good. Okay, example 4. Using an equation of a linear function to solve a problem. Okay, well, let's give this a try. Okay, to join a local gym, Kareem pays a startup fee of $99 plus a monthly fee of $29. So write an equation for the total cost, C dollars, for n months at the gym. Okay, so the total cost is C. Okay, now the slope here, the slope is going to be the rate of change. It goes up by $29 every month. So that's going to be 29 n's. And we have that initial startup fee, so the y-intercept is going to be 99. Okay, so our slope, again, is 29. Our y-intercept is 99. So cost equals 29n plus 99. Awesome. So suppose Kareem went to the gym for 23 months. What's the total cost? So this 23, that's an n. So we just put that in to the n. So the cost would be 29 times 23. And did you guys see that when I substitute, I put the brackets in just so that I know that this 23 was the n. Okay, and then plus 99. Okay, so when you type that into your calculator, you get 1,056. Okay, suppose the total cost, or sorry, that's it for B. So C, suppose the total cost was $505. For how many months did Kareem use the gym? So the total cost is 505. So cost, so 505, that's the C. So that's 29 n's plus 99. So it just makes this little algebra equation. Okay, and you guys have been solving this for a while now, so we have to peel off the plus 99 first. Okay, so 505 minus 99 is 406 equals 29 n's. So 29 is timesing the n, so we have to divide by 29, divide by 29, and n equals 14. So Kareem used the gym for 14 months. Okay, and then could the cost ever be $600 exactly? Oh, well, there's a couple of ways we could do this. Okay, the first of which is to solve it just like we did with C. Just put in 600 into the n, pardon me, 600 into the cost, and solve for n. If it works out nicely, then sure, it can equal $600. If it doesn't work out nice, then that number wouldn't work. So 29n plus 99. Okay, so again, minus 99. So 501 equals 29n divided by 29 divided by 29. So n equals 17.3 months. So no, this number is not possible. Okay, because yeah, you would, if you get into past your 17th month, you would have to pay for the whole 18th month. So yeah, the 600, it would never work out to that. All right. So next one, find the equation through the line AB in slope-intercept form if A equals negative 4, 1 and B equals negative 8, 8. Okay, so if we start with y equals mx plus b, okay, first things first, okay, you can figure out the slope between those two lines. That's pretty easy. x1, y1, x2, y2. So the slope, okay, so y2 minus y1 over x2 minus x1. Okay, so let's see, that's 8 minus 1 is 7, and the double negative makes a positive, so negative 8 plus 4 is negative 4. So you can, and we don't leave the negative on the bottom, so the slope here is negative 7/4. Okay, awesome. So that's the slope. Now, neither one of the A or the B are y-intercept. We can tell if because the y-intercept always has x equals 0. That would just be too easy. Okay, so what we do is we have to use algebra. See, and we have this nice little formula. Now look, it has 4 variables. Now, the way we've taught you algebra is that you can only solve for one variable at a time. So let's put in that slope. So y equals negative 7/4 x plus b. Now, the funny thing here is there's still 3 variables. But look, there's choices for x and for y. So tell you what, it doesn't matter which point you pick. Just pick one. And I will do it twice, just so you can see that it doesn't matter. But you will only have to do this once. Okay, so I'm going to start with the with B. Okay, so the y coordinate is 8. Okay, so that's going to be negative 7/4 is the slope. The x coordinate is negative 8 plus b. Oh, look, see, there's only one variable now, so now you can solve that. Okay, so negative 7/4 times negative 8. Okay, so that, when you type that into your calculator, that works out to positive 14 plus b. Okay, and then we have to go minus 14 minus 14. So 8 minus 14 is negative 6. So b equals negative 6. So once we have the b, then we can put the x's and y's back into the equation. So y equals negative 7/4 x minus 6. So that's how we can get the equation from the 2 points. So again, I told you that I would do that for the other point, just so you could see that they're the same and it's not going to make any difference. Okay, so again, we go negative 7/4 x plus b. Now let's sub in the other point. Okay, so the y on the other point is 1, and the x on the other point is negative 4 plus b. Okay, so negative 7/4 times negative 4 is positive 7, so 1 equals 7 plus b. So then minus 7, and negative 6 equals b. Hey, look, they worked out to the same b's, which means when we put the x's and y's back in, they have the same slope, negative 7/4 x minus 6. So either point you use, you will get exactly the same b. So again, please, 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 can't stress this enough, never do it twice. Okay, only pick one of the points. They're going to work out to be the same. I just did that to show you. Okay, so let's try it again for B. Find the equation through line CD in slope-intercept form. So again, that's y equals mx plus b. So we need to figure out the slope. So the slope here, so let's see, x1, y1, x2, y2. Okay, so the slope would be negative 2 minus negative 5 over negative 6 minus 3. Okay, so that's you just plug in those numbers. Hopefully you're good at the slope by now. Okay, so the double negative makes a positive, so negative 2 plus 5 is positive 3. Okay, and negative 6 minus 3 is negative 9. Okay, so 3 over 9, that reduces to negative 1/3. Okay, awesome. So that's the slope. So now we go y equals negative 1/3. That's the m, right? The slope is the m. X plus b. And then we just pick one of the points. again, it doesn't matter which, so I'm going to choose to pick the first one. Why not? You got to pick one, so whatever. Okay, so the y value is -5. So 1/3 is the slope, -1/3, and the x for that one is 3. The only rule is you have to pick the same, or the coordinates from the same point. Like you can't pick the x coordinate from C and the y coordinate from D. Like why would you do that anyway? But you can't do that. You have to be consistent with the point. Okay, anyways, so plus b, so -1/3 times 3. Okay, you can do that in your head, use a calculator, doesn't matter. Either way, that works out to -1. So -1 plus b, okay, and then +1 plus 1. So -5 plus 1 is -4. So -4 equals b. So then we put our equation back together. So y equals, so -1/3 x minus 4. Now, if I really wanted to graph that, I certainly could, because we know that the y-intercept would be -4, 1, 2, 3, 4, and our slope is -1, and then 1, 2, 3 over. So then you can graph that really super quick. Okay, so we're almost done this section. There's just a few more little things to talk about. Horizontal and vertical lines. Okay, so recall that a horizontal line has a slope. Okay, so to put this into y equals mx plus b form then is really quite easy. Because if the slope is 0, y equals 0x plus b. Okay, so 0x, 0 times anything is just 0. So this works out to y equals b. So the b value is just the y-intercept, or a constant term. So that's why I made it a c here. So all horizontal lines take the form of y equals some constant. Okay, so where c is the y-coordinate of any point on that line. Okay, awesome. Vertical lines are slightly more challenging and require us to think differently. Recall that the slope of a vertical line is undefined. Okay, we can't just put that into an equation like we did with the zero slope. Okay, but if we look at a vertical line, we can get some clues. Okay, now you've already sort of seen this one, but we're going to do it anyway. Okay, let's consider the vertical line through x equals 2. Okay, I had you draw a vertical line on your calculator last chapter, okay, and that was -2, but that's okay. So tell you what, let's just analyze some points here. So that point is the point 2, 0. Okay, this point right here, that's the point 2, 1. Let's see, this point up here, so that's 1, 2, 3, 4. So that's the point 2, 4. Let's try one down here. So this is the point 2, -2. Okay, if you look at all of those points, look, all the x coordinates are 2. So recall a vertical line is an x equal line. So it's x equals, okay, and then what does x equal? Well, on this line, it's x equals 2. Okay, so in general, a vertical line then takes the form of x equals some constant. Okay, and that constant is the x-coordinate of any point on the line, because the x-coordinates are going to all be the same. Okay, so horizontal lines are always y equals a number line. Okay, and then a vertical line will always be an x equals some number kind of line. All right, so that's that. Okay, so example 6. Find the equation of horizontal and vertical lines. Okay, so find the equation of each line, or of the line in each case. So we have a horizontal line passing through 5, 6. So remember, horizontal lines are y equal lines. So y equal lines, okay, and then what does the y equal? Well, the y equals 6. So y equals 6, done. That's it. So vertical line passing through 4, 3. Remember, a vertical line is an x equal line, and x in this case equals 4. Awesome. So we need the line passing through 2, 3, and 2, 7. Now, you could actually figure out the slope of this if you really wanted, but oh look, the x coordinates are both 2 here. So we have a line at 2, 3 and at 2, 7. Hey, that's a vertical line. Well, vertical lines are x equal lines, and x equals 2 in both cases. Awesome. Okay, what about this one? The line passing through 5, 2 and 10, 2. Oh, hey, look at that. These, the two y coordinates are the same, which means if we were to draw this really quick, 5, 2 is about there, 10, 2 is about there. Oh, look, that makes a horizontal line. So that's a y equal line, and y equals 2. Now, I should say here, like, when you get into your exam and your formative assessments and whatever, like, you're going to have these things. So you might just jump right to the slope formula. Okay, so 7 minus 3 over 2 minus 2. So you would get 4 over 0. Oh, okay, well, as soon as you see the over 0, okay, now that's undefined, so now you know it's a vertical line. Okay, so you might not notice that right from the points like I did with C and D, but you would notice it when you figured out the slope. Same thing applies with this one. You'd go 2 minus 2 over 10 minus 5, so that'd be 0 over 5. Oh, wait, the slope here is 0. Well, a 0 slope is a horizontal line. Okay, awesome. Okay, so E, the slope is 0, so that's, again, horizontal. Okay, so that is a y equal line, so y equals 8. Awesome. So undefined slope, remember that's a vertical line, so that is an x equal line. So x equals, well, whatever the x coordinate is, so -5. Okay, and it's that easy for those ones. So that's it for this section. It's section 6.4 in your textbook, starting on page 362. Make sure you show your teacher when you're done so they can check your progress. And good luck, everyone. Talk to you soon.